So today we're going to learn a problem-solving technique called dimensional analysis, and it's the technique we use to solve problems in chemistry. Okay. And all dimensional analysis means is you just use units or dimensions that are part of a measurement to help solve or analyze problems. Okay, so when we do dimensional analysis, we use conversion factors. You do need to know what a conversion factor is. So a conversion factor, it's a ratio of equivalent measurements. Okay. And the key word for the conversion factor is equivalent. What does the word equivalent mean? The same or equal. Okay. So whenever you use a conversion factor, they have to be equal. So for example, $1 is equal to 4 quarters. So that's an example of a conversion factor. Does $1 and 4 quarters have the same monetary value? Yeah. Yes. Okay, that's what we mean by they have to be equivalent. Another example could be 100 pennies is equal to 10 dimes. Okay. These two, are they equivalent? Good. Okay, 1,000 millimeters is equal to 1 meter. Again, if we were to measure out those lengths, they're the same length. Okay. 1,000 grams and 1 kilogram is a conversion factor. If we were to weigh something, 1,000 grams weighs the exact same amount as 1 kilogram. Okay. When we write conversion factors, we write them so they look like a fraction. Okay. The key is, though, they still have to be equal quantities. Okay. So let's say we're using the example of 1 inch equals 2.54 centimeters. Okay. We're actually going to write that in fraction form. So let's say we put 1 inch in the numerator, we put 2.54 centimeters in the denominator. Okay. These two values still have to be equivalent, and they are. If we measured the length of something, 1 inch is the same length as 2.54 centimeters. Okay. Or we can flip them. We can put 2.54 centimeters in the numerator and 1 inch in the denominator. Okay. So and I'll teach you, like, how do we know which one goes in the numerator or denominator? Okay. The key is that people make mistakes on. When you set it up in fraction form, these two values have to still be equal. Okay. So we're going to figure out how many minutes are in 2.5 hours. Before we just dive into the problem, we're going to do something that I call a game plan. So we're going to make a little plan about how we're going to go about and solve this problem. Whenever we start with the only number given in the word problem. Okay, so what's the only number given? 2.5. And what's the unit? Hours. So when we write our game plan, we're just going to write the units down. So you're going to have to start with hours. Do you know how many minutes are in an hour? Yes. Okay, so then we're going to convert from hours to minutes. So then now to solve this problem, you're going to draw a set of boxes. And they're eventually going to look like boxes, so kind of hang with me here. Okay. The number and unit given in the word problem is going to go in the top box. So I'm going to write 2.5 hours in the top box. Okay. In the bottom box, right here, you may either leave this blank, or if you don't like an empty box, you can put the number 1 there. By adding a 1, is it still 2.5 hours? Okay, so adding a 1 doesn't change anything, it just fills the box. Okay, so now we're going to convert between hours and minutes. How many minutes are in an hour? 60. Okay, we know it's 60 minutes in an hour. The name of the game is unit cancellation. If hours is up here in the numerator, the unit hour has to go down here in the denominator, so they'll cancel out. Okay, and so there's 60 minutes and how many hours? One. Just 1. So in the bottom box, I'm going to write 1 hour. And then in the top box, I'm going to write 60 minutes. Okay, I'm going to strongly encourage you, cancel your units. So if hours is in the numerator and the denominator, those units cancel. So physically cross them out on your paper. And then the only unit that doesn't cross out is minutes. Does that match the unit we're trying to end in? Okay, so that's how we know we're finished. We don't have to draw any more boxes. Okay. And then on the previous slide, we talked about how your conversion factor had to be equivalent. So that's what this is right here. Is 60 minutes the same length of time as an hour? Okay, so whenever you set up your conversion factor, just check in with yourself. Are those two values equal? And then how we do the math on this, you're going to multiply the top row. So what's 2.5 times 60? 150. Then you'll multiply the bottom row. What's 1 times 1? Okay, and then now you just divide 150 divided by 1, which is, okay, 150. Okay, we are going to count significant figures. So we always round our final answer to the correct number of significant figures. How many sig figs are in 2.5? 2. Have we defined 1 hour as 60 minutes? Is that a definition? Okay, so we don't count that for sig figs. So if we started with 2, how many need to be in our answer? 2. And how many do we have? 2. Okay, so is 150 fine? Okay, the last thing we're missing is a unit. What's the unit? Okay, so your final answer should be 150 minutes. Okay, this time we're going to figure out how many seconds are in 2 days. Okay. What's the only number in unit? Like, what's the only number given in the word problem? 2. And what's the unit with that? 2 days. So you have to start with days. Okay. So we're going to make a game plan first. Okay. So are you with me here? Because you're given the number 2 and the unit's days, you have to start with days. And then where are you trying to end? Like, what unit does your final answer need to be in? Seconds. Do you know how many seconds are in a day? Okay, I don't either. What do you know that's in a day? Okay, we know hours. So can we convert from days to hours? Okay. Do you know how many seconds are in an hour? Okay, what do you know?
60 minutes in an hour.
Okay, so we know minutes. And then do we know how many seconds are in a minute?
Yes.
Okay, so step 1 is to make that game plan. If you're not quite sure how you're going to convert your units, do you really have much hope to do it while you're trying to set up the problem? Okay, so don't skip the game plan step. So now that we have a game plan, we can draw our set of boxes. Okay. And then what number is going to go in that very top box? 2. 2 what? Okay, so we're going to write 2 days. And then we're just going to follow the game plan. So we're going to go from days to hours. So how many hours are in a day? 24. If the unit days is up top here, what unit has to go down here? Okay, so it has to be days. And we're going to put 1 day. How many hours are in 1 day? Okay, then physically cross off your units that cancel. So days cancel. So that leaves us right here in the game plan. So now we're in hours. We know we're in hours because we haven't canceled them yet. Okay. We have to get to minutes. How many minutes are in an hour? Okay, if the unit hours is up top here, what unit has to go in the bottom? Hours. And how many hours are we going to write? Okay, so 1 hour. And how many minutes are equivalent to an hour? Okay, so I'm going to write 60 minutes on the top. Okay. And then physically cancel out your hour units. Okay, so then we're in minutes. So I'm right here in the game plan. And we have to get to seconds. How many seconds are in a minute? Okay, if the unit minute is up top, what unit has to go down here? Okay, and how many minutes? Okay, 1 minute. And how many seconds are equivalent to 1 minute? Okay, so again, you're going to physically cross out minutes. What's the only unit that didn't cross out? Okay, do you see how seconds matches our final unit? Okay, that's how you know you're done. Like, I'm done drawing more boxes. I'm ready to calculate. How do you calculate the top row? Okay, multiply all the way across the top row. Okay, 172,800. Okay. Multiply the bottom row. What do you get? 1, and now we just divide. 172,800 divided by 1 is?
172,800.
Okay. And then there's two ways you can look at the significant figures for this one. If you consider 2 days to be an exact number, so let's say it's exactly 2 days. Okay, so exactly 2 days. If it's an exact number, we're not going to count it for sig figs. Okay, and then have we defined a day as 24 hours? Okay, so we wouldn't count it. Have we defined an hour as 60 minutes? We wouldn't count it. Have we defined a minute as 60 seconds? We wouldn't count it. Okay, so if we want to look at this as exactly 2 days, we're not going to round this at all. Okay, so a full 2 days is 172,800 seconds. Okay. If you wanted to consider 2 days as a measurement of like just how many seconds are roughly in 2 days, then you would round it to 1 sig fig, which what is this going to round up to? Okay, so like if you're going to be like, well, like just roughly 2 days, how many seconds? It's just like roughly 200,000 seconds. Okay, I'm going to keep it as an exact number for now. Okay, how many cups are in 120 teaspoons? And then I gave you the conversion factor. There's 48 teaspoons in a cup. I put that one down because I figured most of us probably don't just know that. Okay. What unit do you think you're going to start with? Okay, the teaspoons, you have to look at the number given in the problem. So it's 120 teaspoons. So for the game plan, we're going to start with teaspoons. And what unit do we need to end in? Cups. Do we know how to convert between teaspoons to cups directly?
Yes, it tells us.
Good. So I can go straight from teaspoons to cups. Okay. What number is going to go in your cat box? Okay, 120, make sure you put the unit teaspoons. And now we're going to go directly from teaspoons to cups. How many teaspoons are in a cup? Okay, does that 48 go in the top box or the bottom box? Okay, why the bottom? Okay, the unit teaspoon has to cancel. So then what are you going to write in the top box? Good. 1 cup. Okay, so teaspoons canceled. The unit cup didn't cancel. And what unit do you want your final answer to be in? Cups. So that's how you know you're done. So now go ahead and multiply the top row. So what's 120 times 1? Okay. And then you're going to multiply the bottom row. So what's 1 times 48? 48. And then now you'll just divide them. So 120 divided by 48. 2.5? Okay, what's your unit? Okay, cups. Last step is going to be to count the significant figures. How many significant figures are in 120? Okay, 2. How about 48? 2. So how many should your answer have? 2. How many does it have? 2. So are we good? Good. Okay, let's say you have $7.25 in your pocket, but instead of having dollar bills, they're all in quarters. So how many individual quarters do you have?
A lot.
Okay. A lot. Okay, what unit are you going to start with? You're going to start with dollars. What unit do you need to end in? Okay, quarters. Do we know how many quarters are in a dollar?
Yeah.
Good. Okay, so let's set this one up. What number goes in the top? Okay, 7.25, and it's dollars. Oops, that's a 5.
You know how to count numbers.
Okay, how many quarters are in a dollar?
4.
4. What number has to go in the bottom here? Dollar. And how many dollars?
$1.
$1. What goes in the top? 4
Quarters.
quarters. Okay, so your dollars cancel. What's 7.25 times 4? 29. What's 1 times 1? 1. What's 29 divided by 1? 29? Okay, so 29, and what's your unit? Okay, a rattlesnake is 2.44 meters long. How long is it in centimeters? I'm going to write the conversion factor up top. I want you to try to do this one on your own, and I'm not looking for the final answer, I'm looking for the boxes. Okay, so when I come by, I'm looking for have you set it up correct. Okay, first we're going to make that game plan. What unit are you going to start with? Okay, then what unit are you going to convert to? All right, so then what number goes in the top box? Okay, 2.44 what? Okay, meters. What number went in the next bottom box? Like this box right here. 1 meter. What goes in the top box? Okay, meters canceled. So what's 2.44 times 100? 244. What's 1 times 1? Okay, 244 over 1 is? Okay, sig figs. How many sig figs are in 2.44? 3. When you go from metric to metric, these are definitions, so this doesn't count for sig figs. So if you started with 3, how many should you end with? 3. And finally, what's your unit? Okay, so you should have 244 centimeters. How many seconds are 1.4 days? Do you want to do this one together or try it on your own? How about you try it on your own and then we'll go over it. So to solve this problem, we're first going to start with making that game plan. So the number given in the word problem is 1.4 days. So that means we're going to start the unit days. And we have to convert to seconds. Do we know how many seconds are in a day? We don't, but what do we know? So we know how many hours are in a day. And do we know how many seconds are in an hour? No, but what do we know? So we know how many minutes are in an hour, and then we know how many seconds are in a minute. So this is the plan we're going to follow. Okay, so now I can draw my boxes. 1.4 days will go in the top box. And so now we have to get from days to hours. So I know for every 1 day, there's 24 hours. So days cancel. And now we're in hours. So now we're going to go from hours to minutes. So now for every 1 hour, there's 60 minutes. Hours cancel. And now we can go from minutes to seconds. So for every 1 minute, there's 60 seconds. So again, minutes cancel and only seconds are left. So now we're going to calculate by multiplying across the top row. Okay, so when we multiply across the top row, we get 120,960. If we multiply across the bottom row, we get 1, and 120,960 divided by 1 is just 120,960. For sig figs, 1.4 has 2 sig figs. The rest of these are definitions, so we're not going to count them for sig figs. So if we have 2 with our starting number, we have to have 2 with our final number. This is our second sig fig, and the 0 is going to cause us to round it down to 120,000 seconds. And then this is asked to put it in scientific notation. So to do that, we put a decimal at the end, and we're going to count how many places we have to move it to move that decimal in between the 1 and the 2. So this becomes 1.2 times 10 to the 5th seconds.